In this video, we're going to take a look at section number 2, problems 1 and 2. So problem number 1 gave you some information about Roadhouse Ribs, who is the only employer of food service workers in the Thatcher, Idaho area. So if they're the only employer, immediately you should be thinking that they're probably a monopsony employer. So there's some friction that we're about to see. We're told that the output price for ribs is $3, so $3 per whatever unit of rib. That the labor supply relation for this worker type is labor supply equals -10 plus 4W. And we're given the assumption that Roadhouse Ribs is a profit maximizing firm in a competitive goods market. Not a competitive labor market, because we've already seen this probably not a competitive labor market, but it's a competitive goods market. And when you have a competitive goods market, the firm doesn't control or change prices of the good that they produce. So we're told that it's $3 and it's going to remain $3. So you're first given some information here to fill out a table. You're told about possible wages, and at those wages, what the quantity of output is. Well, you can suppose that at that any given wage, when you interact that with the labor supply equation, that we can then identify what the number of workers is that creates that output that stems from that wage. So in the first column, we're going to go ahead and fill out the labor supply value, which we simply do by inserting into the labor supply equation the various W's. So to get this labor supply of 22, I took -10 plus 4 times 8, which then gave me 22. Because 4 times 8 is 32 minus 10 is 22. And so you go ahead and fill out the remainder of that column the exact same way. And most of you did that very well, no problems. In the next column, we get the marginal product of labor. And recall the marginal product of labor is equal to the change in quantity divided by a change in labor. Well, as we go from some unknown wage and some unknown labor and unknown quantity, we don't know what they are, so we don't know what they change to, so we don't have anything in this first area here. If you knew that it was $7 an hour, you could identify the number of workers, but you still don't know what the quantity is for that number of workers. So you really don't have the ability to complete this. So here we've got, as we go from $8 to $9 an hour, we go from 22 to 26 workers, so it's 4, 22 to 26. And we know we've gone from 470 units output to 498, so more workers, you would expect more output. So it's a 28 unit change divided by a 4 unit change in labor. So 28 divided by 4 is 7. It's our marginal product of labor. And you go ahead and complete the remainder of the column in that fashion. Well, the marginal revenue product of labor is the marginal product of labor times the price of the output good. So 7 times 3 is 21, 6.5 times 8, or rather 3 is 19.5, 6 times 3 is 18, and so on. So you complete the column in that fashion. If we didn't have marginal product of labor, we can't have a marginal revenue product of labor because it would be then unknown times 3 is still unknown. So in the next column, total cost of labor, we know total cost of labor is wage times labor. Total cost of labor, wage times labor. So 8 times 22 is 176. 9 times 26 is 234, and so on. And finally, the marginal expense of labor is equal to change in total cost of labor divided by change in labor. Well, here we've got total cost of labor changing from 176 to 234, and we divide that by 4, and that gave us 14.5. And then 234 to 300 was 16.5, and so on. So what we've seen here is that we have a wage change, and we have marginal revenue product of labor change, we have a marginal expense of labor change, and those all become important because we know that in a general condition, we want marginal revenue product of labor being equal to marginal expense of labor. We suppose that since there's a monopsony employment scenario working here and a changing marginal expense of labor, that marginal expense of labor probably will not equal the wage. That's a result of our friction. It's one of the things that confirms that this is a monopsony, so we move on with that thought. And we know that this is a profit maximizing firm, and they're in a competitive goods market. Well, profit maximizing firms want to have enough workers to maximize the condition of marginal revenue product of labor equals marginal expense of labor. And if it can't equal it, we want to be greater than. So in this case, we look and we say, okay, we can have 21 MRP of L and 14.5. Well, MRP of L clearly is greater than 14.5, but can we have more than 26 workers? And can we have more than 498 units of output? Well, if we go to 30 workers, 524 units of output, we're at 19.5 MRP of L, 16.5 ME of L. That still meets the condition. It's not equal, but it's greater than. If we go to 34 workers and 548 units, now we're at 18 MRP of L, which is now less than 18.5 ME of L. Well, we don't want to go to the point that it's less. We never want to design a loss. So we're going to stop and say that our optimized, our maximum profit maximizing level of labor is at 30, paying them a wage of 10, where MRP of L is 19.5 and ME of L is 16.5. Now you might say, well, why don't we go a little bit further? We know that at something between 30 and 34 workers, we know we probably get to an actual equality where MRP of L is actually equal to ME of L. Well, maybe we do, but if we're going to make a guess here, we're going to have to guess that as we move 1 unit of labor, it's going to be a constant proportional move in MP of L and then MRP of L and ME of L. And we don't have information to tell us that. We know from 30 to 34, we know from 34 to 38, but we don't know from 30 to 31 or 32, etc. So you have to end up with this near equality, where you've defaulted to the condition where MRP of L is greater than ME of L. Otherwise, you've decided to lose money. Or if you allowed it to be more greater, that's a terrible way of saying that, but 21 versus 14.5, we're leaving some quantity output behind, which means we're not selling as much product as we could. We're not making as much money as we could. So if we look at this, the next question is how might you label the type of producer for this firm in the market, and what's the most likely contributing factor? Well, it's a monopsony employer, and the factor is mobility. And we know that the factor is mobility. Think about it. If you were in a situation where you had a monopsony employment situation, you probably are being paid less than marginal revenue product of labor. Look back here. At a wage of 10, MRP of L is 19.5, so that's a lot less. So you're making 19.5 for the firm. The firm's only paying you 10. You're going to look at that and say, you know, if it cost me less than 9.5 to move, I would probably move so that I could get the greater wage. I'd rather go someplace and get 19.5 as long as it didn't cost me less than as long as it didn't cost me more than 9.5 to do it. So mobility is the factor, and the cost of mobility is what's really at issue here. Most everybody got monopsony. Only a few of you picked up that this was a mobility issue, even though we talked about that 2 or 3 times in the videos. In item C, we say how many workers would this firm hire? How much would it pay? Well, I've already identified 30 workers, $10 an hour, and I think you understand why. And we've satisfied this condition. Item D, is we're creating now the graphic model that lets us see this. You've seen this 20 or 30 times by now. We've got a labor-supply relation that is informed by the equation LS equals -10 plus 4W. So we can identify 2.5. We have an upward slope. We know that because it's labor supply. We have a marginal revenue product of labor curve. And you don't know exactly where that lives, by the way. Oh, you can plot certain points on it based upon this, but this is a changing number. And so you don't know exactly where it is necessarily. You have to do some guessing as to where it crosses the axes. So I'm not looking for values at these axes, even if you had a pretty good guess. But you do have that. You do have where labor supply crosses. That's the reservation wage, of course. Remember that. And we know that at the point of marginal revenue product of labor equaled marginal expense of labor right here, that we don't exactly observe that point in our table, so we can't really settle in that particular point. So we settle on the points that we can observe. And we end up with this little bit of disconnect or this little inefficiency. We know that at 30 workers, if you put that into labor supply equation. LS equals 30 equals negative 10 plus 4W. Then the wage is 10. So we can mark all of these, and this is our form. You should have seen this many times. There is no labor demand curve here. If this was a perfectly competitive market, marginal revenue product of labor would be the same curve as labor demand. But we know it's not a competitive input market for labor because this is the only buyer of that kind of labor in the market. So as we now go to problem number 2, this is a compensating wage differential problem. And you don't know that expressly in looking at it, but as I give you some of the language here, that should become fairly apparent. First, I'm just giving you that there is some utility that Lauren receives. And that utility is equal to her income, or the variable Y, times the square root of her leisure, the variable LE, divided by some risk component, the variable R. So this worker, Lauren, gets utility from income, leisure, and some level of risk. So we're going to suppose, unless she's risk perverse or risk loving, that the lower the level of risk, the happier she's going to be. That would make sense to us. And the lower the level of the denominator, the larger the utility is. That would support that. So first, you then are given some information about 3 different firms, A, B, and C. Each one you have an income factor, Y, risk factor, R, and leisure factor, LE. So with that, you can identify the utility level for each of these firms. And if we look here, firm A is going to end up with the smallest level utility, calculated here. Firm B is going to end up with the highest. Firm C is in the middle. So this worker, Lauren, probably, all else being equal, is going to prefer firm C over firm A, and firm B over firms A or C. She's looking for the highest level utility. That's what we do as consumers, workers, etc. But here you've simply given me the calculations. By the way, very few of you actually chose this question, and I believe this is probably far and away the easiest question on the exam. But I think that this equation kind of intimidated a few of you. This is not a difficult equation. Don't let square roots bother you. They're simply keystrokes on your calculator. So the next question here is from which of the firms would you expect Lauren to accept an offer? Well, she's going to accept an offer at the firm that gives her the greatest utility. We already identified that was firm B. And here we've asked you to give us kind of a graphic model of this in wage and risk space. So wage and risk space. Well, there's another space available here, and that is leisure space. But that would create a 3-dimensional model. I haven't asked you to consider 3 dimensions, so I just want you to consider these 2. And as long as you gave me 3 isoprofit curves, which you know are specific here in a compensating wage differential model, you would expect them now that I've told you that's exactly what we're looking at. And you would expect them to be in wage and risk space. They're going to be monotonic, they're going to be concave, and they're going to be different than each other, of course. These don't look exactly like some that I've shown you. You might have expected them to just kind of line up nice and neatly in arcs progressing here like an offer curve in wage and risk space, because we have a third element to think about here. So we really have something that's 3-dimensional. We don't get to observe all elements of its dimensionality. We only get to look at the 2. But as long as you gave me 3 isoprofit curves and gave me Lauren's indifference curve running tangent to the isoprofit curve of firm B, validating this choice, then that worked for me. And they should go ahead and match up with the risk and wage levels that are part of the description in part A, or rather for the description in the story that I told here. Finally, we go on and say, okay, let's go ahead and give some detail with respect to the indifference curves and the isoprofit curves. So the indifference curves are for a worker, isoprofit curves are for a firm. There's a lot you could have said here that would have been accurate. Clearly, there are some things that are inaccurate, but there's a lot you could have said here that would be accurate. So what I'm looking for are just 4 or 5 elements that give us some understanding of these curves. Most of you that did tackle this did this part very well. A few of you that tackled it gave some very general things that weren't quite on point. But we're looking for in the indifference curve or the utility curve, saying that the level of utility is constant at any point on the curve. That's part of being an indifference curve. If it's in wage and risk space, then it's convex. Or if it's in wage and benefit space, it would be concave, of course. It's monotonic, which means it's not changing directions. If it's wage and risk space, as utility rises, the curve shifts up and to the left. So if this curve goes from UL to just U, up and or to the left, well, it's a higher level of utility. How do we know that? Because at a given level of risk 3, let's say, we have a higher wage than when it was at risk 3 and wage 6. Well, if we get utility from wage and risk, then more wage, risk being constant, we have higher utility. So that would be some of what you might have told me about an indifference curve. With respect to an isoprofit curve, then you would give me some information saying the constant level of profit at any point on the curve. And by the way, unless you're given information to the contrary, the level of profit at each of these isoprofit curves should be equal to 0. Because this is a competitive firm, you can presume that at the very least if you're not told. If you're told differently, then it's not a competitive firm. But unless you're told, then you have to presume it to be a competitive firm, and profits are 0 when we're in competition. Well, so it's constant level of profit at any point. Again, it's monotonic. Once the curve starts, it continues on in the same general direction. In wage and risk space, it's concave, so it looks more like the mouth of a cave than it does anything else. If this was wage and benefit space, it would have been convex. And then as profit rises, the curve shifts right or downward. And let's look at that. Let's say we go from C to C prime for this firm. Well, let's think about this. At same level of risk, 4, if it is shifted down, we're at a lower level of wage. If wage has declined, but the risk mitigation cost has remained unchanged, then this company has lower costs, ergo they have higher profits. So that's how we would have looked at this.